Hi, welcome to this lesson on calculus, finding tangents to functions. So before we do that, we want to have a look at the properties of straight lines again and just go over them. So some straight line terminology, we have the straight line equation, which is known as the gradient point form. So we say that if line AB has a gradient of AB, and we only know a single point on the line AB, let's call it this point here, P, x1, y1. Then we can work out the equation of that straight line as follows. So if we know the gradient value, gradient is y minus y1 over x minus x1, right? That's the formula for gradient, change in y over change in x. Then what we can do is we can cross multiply both sides by x minus x1, and we'll get m times x minus x1 equals y minus y1. And therefore, if we add y1 to both sides, we just get y by itself equals m times x minus x1 plus y1. So for example, if this point P was the coordinates 2, 5, and let's say we knew the gradient was 3, then we can use this formula here to instantly write the equation of the straight line. So it'll be y equals the gradient 3 times x minus x1, which is 2, plus the y1, which is 5. And if we distribute that out, we'll have 3x minus 2 plus 5, and we'll have 3x plus 3. And that will be the equation of that straight line. Okay. Next, we have what we call the two-point form. So again, if a straight line has 2 points now, P and Q, then we can work out the equation of the straight line as follows. Well, we do the similar thing. We know gradient is y2 minus y1 over x2 minus x1. So we can work out the gradients of the straight line. Once we know the gradients, then we can come back and do the gradient point form again and choose any one of these 2 points. All right. And then lastly, we have the gradient intercept form, which is usually the most commonly used one. So this means if we know the gradient and a single point, or if we have 2 points only, we can use the gradient intercept form. So it's a combination of these previous 2 ones. Okay, and that's commonly referred to as the standard form of a straight line, y equals mx plus c, where m is the gradient and c is the y-intercept of that straight line. Some other properties of straight lines that are important to know are parallel lines. So two straight lines are said to be parallel if they have the same gradient. That's really important. So this means that two parallel lines in the Euclidean plane, right, the Cartesian plane rather, they will never cross each other. Right, in any direction. They'll carry on in the same direction forever in both ways. We write AB as parallel to CD in geometrical notation, right, to represent that these two are parallel lines. And perpendicular lines, what are these? These are two straight lines that meet at a 90 degrees. So they intersect at 90 degrees. All right, and when you have lines that are perpendicular or parallel to the x and y axes, then these lines also meet at 90 degrees. There's a very special result when it comes to perpendicular lines that in these two cases here, right? The gradients of the one, so for example, if this was 3, the gradients of this one would be negative 1/3. So when you multiply the two gradients of perpendicular lines, you get negative 1. Right, and similarly here, if m was equal to a half, then this gradient here would be negative 2. All right, so those are some of the properties of straight lines. We need to make sure that we understand these properties of straight line functions, because we're going to be using them now when we talk about tangents to a point on any given function. All right, so that is how we would do the properties of straight lines. We're going to use those now and work out them when it comes to tangents at a point to a function. All right, I'll see you in the next one.